Good evening, sir.
Good evening. Good evening.
Good evening, sir. Sir,
he experienced after knowing the words, after seeing 1 crore rupees currency. He saw the particular person who sold his property, and he.
good evening, sir.
Raghavan sir, good evening, sir. Kumar sir, good evening. Welcome, sir. Good evening, sir. Raghavan sir, welcome. Good evening, sir. Very much happy to see you. The other side is our chairman, sir, Mr. Kumar, GM, General Manager in charge. You don't knowing him. He was the engineering head.
Sir.
Our past chairman of
good evening. Yeah, you told me about it, yes.
Oh, right, sir. Thank you, sir. Very nice, sir, to hear you once again. Really, the other day I enjoyed your talk. That's why he made us to invite you today.
Thank you.
Really, it was a very good talk on the day. Actually, I'm very much fond of the solar, knowledge related talks. So it was very much useful for me.
Thank you, sir. We can be continuously in touch after the meeting also.
Yeah, sure, sir. We are doing it for the past 3 decades, sir. Actually, without all our previous chairman and all done a wonderful task. From 88 onwards, every Tuesday we conduct program.
Oh, good.
After the pandemic, we switched over to this the virtual mode. Again, we are next year onwards, we'll go for hybrid mode rather than physical mode. So people can participate from outside world and also people can talk like you. Eminent paper, we can invite without their travel. So.
Sure. Nice
Sometime
to know,
back,
actually.
2 months back, Mr. Sundar Vedandam from Intel director from USA delivered ethics in information technology. Really, it was a very good show. Like that, many people were roaming from around the globe. That's all.
Oh, good. That's what I was pleasantly surprised to know that you got more than 10,000 members. 10,000 corporate members.
Exactly.
It's a very big number.
Yeah.
Bangalore IIT chapter.
Which unit once upon had a 12,000 employees strength. Now, because of that, we promoted in a very big way the membership strength and by canvassing to all the people. And today it has come down a lot.
We are making drive under the new chairmanship. We are driving again membership drive. We are doing it. So Balasubramanian is doing a lot of job in promoting new membership. That's what.
Okay. I think he's in Delhi now, no?
Delhi is having a lot of plans to improve membership 2,000 to 3,000 corporate members. Okay. Student members again, it will be improved after once the AME is recognition convent, they will come. They will automatically come.
Okay.
Boundaries from Ariyalur, Paramur, Karur, Pudukkote up to Nagapattinam. It's a very big area.
Oh, very big area. Okay.
Excepting Tanjore, all the engineering colleges, we support all the engineering colleges, all the institutions, industries. Many people are members. That's from a academic as well as PW, State Electricity Board, like that. BHL, major people are from BHL.
Okay. This Tanjore is a separate chapter, is it?
Yeah, they wanted to go for separately. Some with 400 numbers, they gone separately.
Once upon a time, it was part of Trichy. Then they became bigger in number, and so this Shastra to be going. They promoted, and then we have to agree for their.
Okay.
Ramachandran was there. He is no more. He took a lot of interest to open a branch there. Okay, we encouraged them and we supported this.
Okay.
But ours is a very small one. It's only some 300 to 400 numbers. Ours is 2,000 plus corporate plus 1,000 students.
Yeah, correct.
It's our mother institution. You come to BHL Trichy, sir? Yes, sir, in time?
Yeah. My initial training, I joined as engineer training in 1977.
Oh, very good.
Then 3 months I spent in a boiler plant. They taught us how to do welding, working on some milling machine, all those things.
Boiler plant, which area, sir, you were there?
That's a general training. There'll be lectures. That is that time. Charles Norman was.
Charles Norman, yeah.
Yes.
Training center at that time it is called. Now it is.
Yes. So we used to come to the training center. Then sometime in the boiler plant to give welding experience, And then there are some theoretical lectures also.
Oh,
And then I spent some time in SSTP.
Yeah, most of the people from ISG group, they were spending time in SSTP for commissioning the industry.
Yeah, correct. That was SSTP. After that, I did not come for that. I came later for one development trial in the non-destructive test bed, NDT. I used to work on variable speed AC drives.
That you must be knowing Ashok Mohindra and all. Ashok Mohindra.
I know very well. We have worked together.
Yeah. So he was also here at that time. He belonged to my batch, 76.
Okay. He was in ISG, and then later on he was transferred to PEM, Delhi.
Raghavan sir, have you checked the PowerPoint, sir? Rights are given to you. Just put it, sir. Check it. So we'll start, sir.
Oh, I will share the screen and check.
Yeah. Already sharing rights are given to you. Please share it, and we'll check it. And if it's okay, now we'll proceed, sir.
Are you able to see the screen?
Yeah. Yet to come, sir. Yet to come. It's not it. Yet to come.
Not yet. Oh, I have to share. Okay.
Share screen you have to put.
Now you are able to see.
No, we are yet to come, sir. It came and gone actually.
Yeah. This home page.
Visible now?
Yeah. Now we make it this thing, sir. Full screen, sir.
I'll make it full screen.
Make it full screen, sir.
IIT call is just 1 minute.
Oh, okay, no problem.
Hello. Prakash sir, சொல்லுங்க. Hello. இது அந்த திருச்சி சாப்டர்ல அது இப்பதான் லெக்சர் ஸ்டார்ட் ஆக போகுது. நான் அப்புறம் பண்றேன் உங்களுக்கு. அப்புறம் பண்றேன். ஆமா பிசிக்கல் இல்ல, ஆன்லைன்.
Bottom cup will be there, sir. The cup, if you push it now, it will become full, sir.
Now
it has come full, sir. Yes, sir. Okay. Now shall we start the program, sir, with your permission?
Yeah, we can start the program. Let me go to the.
Yeah, it's moving. Screens are moving, sir.
Okay. I just first page.
Then go to the first slide, sir, so they will start the program.
Then you command to go to the first page straight away, or you have to go through like this only?
No problem.
I got to the first page.
Okay, sir. Right, sir. Okay, sir. Very good evening, sir. Really, it was a good day. We are celebrating Institute of Engineers, the Chamberlain Local Center. Am I audible, sir?
Yeah.
Okay. Happy good evening to everyone. Really, it's a day we celebrate every year. Institute of Engineers, our headquarters say the one day, that is tomorrow is our energy consumption day. But our custom, we celebrate our Tuesday. We conduct our programs. So it makes Tuesday means our Engineers Day, where we conduct a regular evening program. And after the shift of BHL closes, we used to conduct physical mode. After the pandemic, we switched over to this virtual mode. It is our 157th program today. That is what. And we are very happy to invite our chief guest of the day, Engineer R. Raghavan, former General Manager in charge Industry System Group, Bharat Heavy Electricals Limited, Bangalore. I happened to hear his lecture last month through Indian Institute of Plant Engineers, where he delivered an excellent talk on the solar. That motivated me to invite him for today's day. Sir, we welcome you, sir. Very much happy to receive you, sir, today. The
Thank you,
topic
it's an
is
honor.
what he is going to deliver is contribution of solar energy for energy conservation. He's going to deliver, as I told you, is Engineer R. Raghavan, former General Manager in charge, Industrial System Group, Bharat Heavy Electricals Limited, Bangalore. And we are very happy to receive you, sir. And first of all, we thank you, sir, for accepting our invitation. Readily you accepted invitation. Thank you so much.
It's a
Really, we
pleasure. It's
institute
an honor for me.
Yes, sir. Thank you, sir. Thank you, sir. The Institute of Engineers for the first 3 decades, our first chairman, first secretary, first office bearers, they have one idea of conducting Tuesday programs. Every Tuesday we used to conduct. BHL is working day means our BHL Institute of Engineers office is located in BHL campus, 3,000 acres campus that is given by the great Kamaraj, earlier Chief Minister, who visioned that our India has to do a lot for in the energy area. In that, our BHL management is promoting a lot of professional activities, and we have more than 10 professional institutions are housed in our campus, out of which our BHL Institute of Engineers situated in BHL campus, and we have constructed more than 2 crores worth of building. That is one lecture hall, AC hall, Dr. APJ Abdul Kalam Hall, with 100 seating capacity, and there is an auditorium 300 seating, Dr. Viswesvaraya lecture hall, auditorium which can seat 300 persons. Not only that, we have 4,000 books library. The first floor of AC, our lecture hall. We have a chairman secretary room. And our aim is to propagate the latest and emerging technologies in all the 15 disciplines. Our membership, corporate membership, more than 2,000 with 7,000 of student members. Not only that, the boundary from Ariyalur, Perambalur, Karur, that is Pudukkote up to Nagapattinam, except in Tanjore. And we do this program. We are a role model to all our professional bodies housed in our BHL campus. And we conduct program. Today's program is organized in association with other professionals. Also, we are taking along with us. That is, they are also associated with us. That is Computer Society of India, Tiruchirappalli chapter, Indian Institute of Welding, Tiruchirappalli branch, Indian Welding Society, Southern Zone, Indian Institute of Metals, Tiruchirappalli chapter, Institute of Industrial Engineering, Tiruchirappalli chapter. Other than that is Indian Society of Non-Destructive Testing, Tiruchirappalli chapter, Kumari Arivel. These are all the institutions joining with us today for conducting this program. So, with this brief introduction, I call upon our former General Manager in charge, BHL Tiruchirappalli Complex, as well as our former Chairman, Engineer Kumar sir, to preside over the function, as well as to welcome the gathering. So, over to Engineer Kumar sir.
Yeah. Good evening to all of you. On behalf of IEI Trichy Local Center, we extend a hearty welcome to all the participants who are participating in this celebration of National Energy Conservation Day. And today's topic is on the contribution of solar energy for energy conservation by Sri R. Raghavan, ex-GMIC, BHL Industrial Systems Group. As you all know, the energy sector importance need not be overemphasized. And particularly the conservation has become a very, very important topic. See, we have come a long way in the last 60 to 70 years from thermal energy generating power from oil, coal, and gas. And then today, the pressure on the environment has made people to go for higher and higher efficiency power plants and also go for green energy also. In this way, from thermal now, in the last 10 years, particularly from 2010 onwards, where the solar energy was picking up, and at that time the unit energy was very costly, more than 8 to 10 rupees or even 12 rupees per kilowatt hour. Today it has come down to some 2 to 3 rupees. So it has competed with the thermal energy, and the last 10 years, the development has taken place in a very big way that today we are having something like 61 gigawatt of installed capacity of solar out of 400 gigawatt installed capacity. That is roughly it is contributing to 15%. So this is now becoming a very big important because it is going to play a very big role, and we have to use the energy very, very efficiently. That is the importance with which this seminar is getting organized. And by 2050, Government of India wants to see that more than 500 gigawatt of renewables are coming in place in a very big way. So as a part of energy management, many companies, industries, even houses, they have started installing rooftop solar power plants, then installation of LED lights, and also installation of solar water heaters, installation of energy efficient AC machines, AC units, etc. So all this now, we have to see that we are using energy in an efficient manner. And in this way, BHL has also played a very, very key big role. I don't know. The number is something like this, about 11.7 megawatt of solar PV has been installed across all the BHEL units to go green in a big way. And today BHEL Trichy plant has got a 5 megawatt solar PV, and it is generating about 14 to 15 million units of electricity. So this is becoming a very big conservation for the industry, because the industry consumes something like 2-3 megawatt of power. And out of this, if solar is contributing in a big way, you can cut down the cost of the many of the operations. And that's why this energy conservation is becoming a very, very important thing. And earlier, see, it's not only the energy conservation in solar, but also we have come a long way using energy conservation in other areas also. In 2005, we started introducing supercritical coal-fired plants in a very big way. Earlier, we were using the subcritical thermal power plants, where the pressure utilized in the steam turbines was below 225 bar. That is the below the critical pressure. That is, we were using the pressure which is of the order of 170 to 180 atta pressure for the turbine boiler system. Today, we are going for high efficiency supercritical plants using pressure as high as 276 bar and temperature ultra supercritical of the order of 603 degrees centigrade. So that's why this unit of energy that is going to be produced is coming down less and less. Earlier, we were using 1 kg of coal per kilowatt hour generated, 0.8 to 1 kg of coal. Today, we are using something like 0.5 to 0.6 kg per kilowatt hour of energy generated. So the efficiency of the plants is becoming more and more important. And in this way, our Sri Raghavan is going to talk how solar power is going to give in a big way the energy conservation, and also help in contributing the reduction of pollution, particularly the CO2 reduction. We are aiming in a very big way. See, earlier we were using only 500 megawatt plants capacity, and to meet the huge capacity addition, people have gone for supercritical, and also associated with supercritical plants, we gone to higher size unit also. From 500 megawatt, we have gone for 800 megawatt. So if you are installing a 4000 megawatt, you have to install 8 into 500 megawatt units. If you are installing a 800 megawatt, you have to put 5 into 800 megawatt. So if you come, the CO2 reduction is going to be something like 1 million ton of CO2 is getting reduced per year if we are using a supercritical plant. So this way, we are trying to see in each area how energy can be conserved, and thereby also promoting the reduction of pollutants. So I feel that this topic of solar energy for energy conservation topic being celebrated as part of National Energy Conservation Day, and Sri Raghavan, who is expert in this field, will be giving a lecture on this. And I welcome you, sir, on behalf of IEI Trichy, to deliver this talk for the benefit of all of us. Thank you.
Thank you, Kumar sir, for an excellent introduction, and welcoming and also stressing the importance of energy conservation in boiler area, as well as the developments going on in whatever in our country in the solar energy area. Thank you so much. Now I call upon Dr. Titus, our committee member representing electrical division, to introduce the speaker to the audience. Over to Dr. Titus, sir. Titus, sir.
Thank you, sir. Thank you.
Yes, sir. Please, sir. Please.
A very good evening to one and all gathered here. I'm happy to introduce today's chief guest and the guest speaker of today's forum on behalf of IEI Trichy local center. I'm happy to introduce Engineer R. Raghavan sir, who is a former general manager, also in charge of the Industrial Systems Group, Bharat Heavy Electricals Limited, Bangalore. For is going to present the topic on contribution of solar energy for energy conservation. So, to introduce today's chief guest, Mr. Engineer R. Raghavan sir has completed his Bachelor of Engineering Honours in Electrical and Electronics from the College of Engineering, Guindy, during the year 1972-77. And also, sir has completed the PG Diploma in Computer Application from St. Joseph's Engineering, Union College, Bangalore, and also a pre-university course from Loyola College, Nugambakam, Chennai. Sir is presently he is a solar coach and consultant since the year 2015. And Mr. Raghavan sir has conducted so many training programs in the area of solar from various topics and from various organizations. And also he has given a guest lecture on solar PV energy and application for electrical engineering students at Loyola College, Nugambakam. And also he has conducted the online solar energy courses and webinars during the month of June and August 2019. And also he has given many online guest lectures during the May of 2020 and November 2022. And sir has given online faculty for course on electric vehicle basics organized by Tamil Nadu Advanced Technical Training Institute, Chennai during the year 2021. And also sir has given a guest lecture for Institution of Engineers, Tiruvallur chapter on solar energy during the month June year 2020. And he has also conducted two-day workshop organized by Mr. Hari Krishna Power and Technologies Private Limited, Solar Energy in Tuticorin in the year 2018. And also 2 numbers of 3 kilowatt and grid solar installation as done by at Bangalore in the year 2017, and 1 5 kilowatt grid solar at Chennai in the year 2019, and another 1 5 kilowatt off grid solar at Maduran Pakam, Changalpet in the year 2020. And as Mr. Raghavan sir has a MSME certificate for solar energy installation and maintenance in the year 2016. And regarding his work experience, sir has a very good rich experience in BHEL and also in the area of solar energy systems. He has worked as a general manager in charge and head of the industrial institute group, BHL Bangalore, since during September 2013 to March 2015. And he is also worked as a general manager at Amravati Power Sector Western Region during March 2011 to October 2013. He is also worked as a business manager at ISC Bangalore and heading the coal handling plant and Asha handling plant business sector during 2010 to 2011. He is also acted as a project manager for NTPC sale plant and also the CHP extension for 1 into 25 megawatt at Hangul. And also he has worked as a project manager for electric for novel project for Indian Navy at Karwar. And another, he has also an experience in a project manager for electrics for Coke Oven and Monarchment Coke Company Limited, Jaipur, Orissa. He is also having an experience on engineering team leader for steel plant projects. And regarding, he has also taken foreign assignments. He has debuted to Siemens, Germany from the April 1998 to October 1989 for process control and computer engineering for the contract of setting up the medium merchant and Andhra Pradesh. And he has also a great experience in development, that is during 1981 to 88. He worked on the development of microprocessor-based DC drives control and variable rate frequency AC drives, including field testing in Salem annealing and pickling line plant. Many technical papers in his area of research and in his area of field on solar energy. His consideration in revamping the type of jobs published in the BHL journal, and also approach paper on variable speed AC drives published in BHL journal, and also published technical paper in reactive power and harmonics for a 12 pulse thyristor converter fed drive system in the electric India journal. So with this introduction, I am happy to introduce today's Chief Guest Engineer R. Raghavan sir for his eminent person to deliver today's lecture on contribution of solar energy for energy contribution. Once again, I thank the committee members and Dr. Selvaraj sir for this opportunity. Thank you, sir. Thank you.
Thank you, Dr. Titus sir, for an excellent introduction about today's speaker and his achievements over the years. Thank you so much, sir. Now the platform is over to Engineer Raghavan sir. Sir, the platform is for you, sir. Go ahead, sir. Please. Sir.
Thank you, Engineer Selvaraj.
Yes, sir.
Titus, and thank you, former Chairman IES R. Kumar. I also thank all the committee members of IES Tiruchirappalli chapter. The audience who are watching this program through YouTube and Zoom, I welcome you all and thanks for the opportunity and the time that you are giving to me. It's indeed an honor to be among a group of 10,000 members, and I hope lecture will be useful to you. So with this, let's wish Happy Energy Conservation Day on the eve of Energy Conservation Day. And the topic today is to, Mr. Silvaraj was mentioning about my talk sometime in the month of November, and that was about solar energy aspects specifically. But here I am trying to make a link between the energy conservation and solar energy. Some difference between there. So with this, let's get started. The problem is that the moment we talk about energy conservation, it means something is, you have to save something. Saving something comes when you have some limitations. So that's what we are going to see now. Now, as our engineer Kumar mentioned, now we are mostly banking on non-renewable energy sources like fossil fuels for our energy, day-to-day energy needs. Even today, 60% of the energy comes from fossil fuels. So we are so much habituated to fossil fuels. Normally, nobody would like to make a change. But why are we talking about a new energy source now? That we will just see in the coming slides. Now, the fossil fuel sources are limited. They are getting depleted very fast, and it has been estimated that over the next 50 to 100 years, at the current rate of depletion, we will not be able to make the fossil fuels. Fossil fuels will get fully exhausted, and we will not be able to use them. So there is a necessity to find an alternative energy source. The law of energy conservation says you cannot create a new energy. Energy can only be transformed. That is, from one, you can convert mechanical to electrical, electrical to mechanical. So you can just take a shape from one form to another form, but you cannot create something new. That means we have to manage with the resources that we have today. So what we are now trying to do is, if somebody says now the fossil fuels will not last more than 100 years, then we have to look for something that is already available that we are not utilizing so far. So that is the thing. Now, somebody may ask, what is the hurry? You are saying 100 years it will come. So why not? We'll see after our next 50 years. Why to do act now? No, the thing is, one is the scarcity. The other is the other effects, side effects. That is, the fossil fuels are causing some damage to the environment. So one is the global warming, other one is the pollution. So pollution means air pollution, water pollution, soil pollution. So we have to handle all types of pollution. Now, so this global warming and climate change is driving the technology change faster. Okay, so because the earth is getting warmer day by day, we are throwing millions of tons of carbon dioxide each year into the atmosphere, more than what the atmosphere can tolerate. And also we are mercilessly cutting trees. So the trees are a good thing of absorbing carbon dioxide. Now we are cutting that also. And number of vehicles on the road, they are increasing. All the petrol vehicles and diesel vehicles are throwing a lot of carbon dioxide into the air. So that is causing a lot of air pollution. So it has reached such an alarming level that government is forced to think about alternate means of energy right now, even though the fossil fuels will last for another 100 years. Another thing is the health effects. See, one is carbon dioxide. Carbon dioxide warms the atmosphere. See, the average temperature of the earth is around 15 degrees centigrade, which is comfortable for a person. That is, if you see without carbon dioxide in a way helps. Some amount of carbon dioxide is necessary to keep the earth warm. If you see the temperature of the moon, it will be minus. So the carbon dioxide to some extent is helpful, but too much now is not helpful. It is making it warmer, causing ice to melt and the rivers to flood. So many things are happening, negative effects are happening. And one other thing is, apart from carbon dioxide, nitrogen dioxide, sulfur dioxide, and then some particles. We see with electrostatic precipitator, we are trapping most of the particles from escaping into the atmosphere. Even then, there are some dust which can be inhaled and it can get into the lungs and create problem, or can get into the brain, bloodstream and create problem. So this is what we are worried. You might have seen in Delhi recently that the air quality has become very, very bad. So what is and Delhi was reporting 300 plus. So that we have to do something on an urgent basis. That is the thing. If you look at the people pushing carbon dioxide, the countries pushing carbon dioxide into the air, China ranks first and India ranks second. I think together we are globally we are sending about 34,000 million tons of carbon dioxide every year, so which is too much for the atmosphere. Concentration of carbon dioxide in the atmosphere has gone up from 200 ppm till 1920. For centuries, it has remained around 200 ppm, but now it is now going to 400 parts per million. So these are the greenhouse gases. Carbon dioxide is the main greenhouse gas that is causing the problem. Methane and other gases, they are more potent than carbon dioxide, but their amount may be small. Methane is 25 times more potent. That means it can, in terms of global warming, it will contribute 25 times. Nitrous oxide is 298. Now, where does the carbon dioxide that we release go? 32%, the carbon dioxide, 66% comes from fossil fuels, 31% from deforestation, and cement and other industries contribute 3%. And 42% goes into the atmosphere, 32% goes into the soil, and 26% gets dissolved in the ocean. So when it's dissolved in the ocean, what happens is the ocean becomes acidic. So that's another problem, because the pH value changes. Here you can see after the industrialization, the carbon dioxide concentration is going up steeply. So this is what we are trying to control. So a 400 ppm of carbon dioxide will increase the temperature by 2 degrees centigrade. And 650, if it goes to 650, 4 degrees right? So a Paris Accord involving all that, because this cannot be done alone by one country. So people have to come together. So a group of 150 countries signed the Paris Agreement, where we will have to bring down the temperature by 2 degrees centigrade. That means so much carbon dioxide must be reduced. Okay. And how it will be reduced? Through lifestyle change. That means we have to use more of renewable energy. We have to replace filament lamps with LED bulbs, and buildings construction should be energy efficient building constructions. Deforestation should be avoided, and disposal of waste also should be taken care, and water purity should be maintained, and transportation should become pollution free. So these are all there. So it calls for total lifestyle change. Okay, this is just an indication that out of 15 most polluted places in the world, there are 10 Indian cities in that list. This is again that Delhi is topping the pollution list. I think yesterday also in the newspaper it has come. Now let's go to a little bit to water. Water is also a scarce commodity. So we see states and countries fighting for sharing of water. So we need to conserve water. water is polluted due to various chemicals thrown from industries and sewage discharge into rivers and ocean. So water as such, we cannot utilize, we cannot drink straight away. We need to purify. So that purification also requires a lot of energy. So not only we must conserve water, we must also have energy for treating the water. So nowadays, recycling of sewage water is taking place in a bigger way. Water is recycled in all gated communities. Without that, they won't get the license. So what sewage treatment plants and water treatment plants are all part of the building. And to run them 24/7, we need a lot of energy. We need to run a lot of pumps and motors. And solar energy is a good choice for such applications where we can really reduce the electricity. These are coming under commercial. So, people are spending lakhs every month, lakhs or 1 or 2 lakhs every month to reduce the energy bills. So solar energy will go a great way in reducing the power bills. Nowadays, hotel industries have started to conserve water. They are not, if a guest is staying in a hotel for more than for 2 days or 3 days, they don't change the linen. They only when the new guest comes, they change, or after 2 or 3 days, they'll change. So they want to preserve water and also reduce the usage of detergents. And you may be knowing that already ash in all thermal plants, ash water recovery system is implemented. So that the ash from the bottom ash hopper of the boiler is mixed with water and sent as a slurry to the ash dike. And the ash dike also, the ash water should not go into the ground. It will spoil the groundwater. So they put some Teflon coating, special coating, so that water does not penetrate or does not seep into the soil. And then they do some decantation wells and clarificator to filter the water and reuse it. So that way they by recycling, there is a lot of water saving in thermal plants. Rainwater harvesting is now done in almost all houses. It is mandatory in many states. And water wastage in railway stations. So you just earlier people used they sense your hand and then the water comes for a limited time. So there is water saving in public places. And some of the day-to-day activities were already, I mean, it's a more of a common this thing. There's nothing, no technology about it. Some of the common lifestyle change that is required to save energy. One is switching off the fans and lights. I think in all offices, cabins, fans will be running whether the person is there or not. So switch off fans and lights will not in use. And leaving the refrigerator open for a long time also consumes energy. And replacement of filament lamps by LED bulbs. So this is implemented in many states. And keeping your air conditioner filters clean. And wherever possible, travel by public transport instead of taking your car. So take your car only when there are sufficient number. So in some of the foreign countries, if you are only 3 or 4 members in the car, then only you can go in the high speed lane. And if you are running a vehicle, don't unnecessarily accelerate and brake even. So this is people just accelerate and come to the red signal and stop. So that is not required. So these type of things, if you change, there will be a lot of saving coming. And avoid frequent. Now in electric vehicles, regenerative braking is a facility given so that when you brake, the energy is converted from mechanical to electrical and stored back in the batteries. And wherever possible, walk or do cycling. And then planting trees. I think if you plant one tree, it takes about 25 kg of carbon dioxide per year. And then whatever clothes are there, people air drying your laundry. So but this is this statement is meant for foreign countries where they use, they don't want to put the clothes in the cloth hanger for drying, but they want to do it with sending heat. So that is lot of energy consumed in that process. So we can try to save it. Then we can go for, instead of conventional, I mean, old air conditioners, we should go for branded air conditioners like 3-star air conditioner, 4-star, 5-star, or inverter ACs, which consumes very less energy compared to the unbranded air conditioners. So these are then improving the power factor at homes. See that people remove the capacitors at the entrance to the mains. People put, I mean, it's required to put a capacitor so that the power factor at the point is at the grid is good. But many people over a period of time it is removed, and then there is a lot of wastage of power on that account. And we can incorporate gadgets to control overflow, tank overflow. Many times we switch on the pump and forget to switch it off, and there is a lot of wastage. And so the basic goal is safe air, safe water, and safe soil. That is the thing. And now that we have seen the negative effects of the fossil fuels, one is scarcity, other one is global warming and pollution. And what the alternative to fossil fuel is the renewable energy. And there are many renewable energy sources. So you have to decide which renewable energy source is best for you. It can be different for our country and some other country. So let's see for our country, the renewable energy sources available, starting from solar, wind, tidal, biomass, hydro, geothermal, and hydrogen energy. Of this, I think we can discount all these things because these are not either untapped, the technology is still not that grown, or they have some limitations. The one that we should consider for our country is solar and wind. They are both competitive. Until 2 years or 3 years back, wind was, the installed capacity of the wind was more than that of solar, but solar has overtaken it. So as of now, I think we are somewhere near 60 gigawatts of solar power installed in the country, whereas wind is, it is at 41, 42, like that it is. So in hydro, the capacity is more or less frozen. It cannot be a substitute for fossil fuels. So only solar plus wind can be a substitute for fossil fuels because they are available in abundance. Solar is available in abundance. See, now whichever energy you are going to choose, you have to ask these questions. One is conversion process with efficiency. That means you are converting light into electrical energy. So that should be efficient. Second thing is it should be renewable. That means each day it is renewed. And second thing is it should be available for a longer period of time. So energy should be sustained and energy should be clean. It should not generate all these side effects. And it should be eco-friendly and at affordable cost. So solar is satisfying almost all of this. It is the cheapest form of energy today. Okay, this is renewable energy is something that replenishes itself automatically. It can be compared to the Akshay Patra. The energy source is infinite, sustainable. So we only talk about solar and wind as a substitute for the fossil fuels. Now, every day the sun is hitting our land, and if it is converted to electrical units, 5,000 trillion units of sun energy every year. So much of light or heat is hitting the earth. I mean, our area, our India. And across the length and breadth, huge solar incident radiation is available. average energy from the solar is 4 to 7 units per square meter per day. So which is very good compared to some of the European countries. On an average, sun is reliably available for 300 to 330. So we discount 1 month for rain and other things, but even then 300 to 330 days is definitely available. And if you take 3% wasteland, we are not going to put solar in an agricultural land. We are going to put solar in a barren land which is not fit for agriculture. So MNRE, which is the Government of India ministry, has identified 3% wasteland for each state and worked out that it has got 750 gigawatts of potential. Now the present installed capacity is around 400 gigawatts, all energy sources put together. So what we are going to get from solar is double of the existing capacity. So it's a very good source. And why we are getting good solar is because most parts of India is located between the equator and the Tropic of Cancer, which receives very good sunshine. This is Chennai is 13, Bangalore is 12, Kanyakumari is 8. So only I think Delhi is slightly Delhi and Jammu and Kashmir are crossing. Now, if you generate 1 unit of solar power, you are saving 1 kg of carbon dioxide. So it's much better than even putting a tree. So by adopting this renewable energy, we can reduce carbon dioxide emission. We can meet our energy needs. Okay. So another scheme which people are, talking and not yet implemented on a large scale is carbon capture. Whatever carbon dioxide that you have sent into the atmosphere, if you can capture and store it and convert it into some sort of fertilizer, then also the problem is solved. But people are working in that direction, but it is still not commercially available. So we have seen that solar and wind have capacity to be a competitor or be a substitute for fossil fuels in the long run, and they are affordable, they are sustainable. So all these things are coming in favor. And today in solar we are ranking, I think this is an old one. I think we have moved to the 4th spot. So we are behind China, US and Japan. Already we have touched around 60 gigawatts. Okay, this is showing the same thing. So total, as I told you, 59.7. So 60% is fossil fuels even today, and 40% is renewable. Out of that, solar plus wind will be around 25%. And this is the energy consumption pattern in India. So slowly, so the progress of the nation can be measured by the consumption. So more consumption means more industries, more growth. Okay. So the energy consumption is an indication of the growth. So this is the pattern. I think some slowdown here due to COVID. I think it will again shoot up. And what is the contribution of the energy sources to the grid? You can see nuclear is very low, hydro and other renewables, but no way comparison to fossil fuels. So that is dominating here. This picture to change the next decade. So as per the government target, renewable energy should be 175, out of which 100 is solar, 60 is wind. So against 100 by 2022, we have done 60. Against 60 of wind, we have done about 40. So that is the equation. And target for 2030 is 500, out of which 300 is solar. Okay, this is division between solar. Solar is around 40. And where we have around 6 gigawatts compared to 40 gigawatt target till now. So this there is a lot of scope for speeding up rooftop solar. So by 2030, 300 should be solar, 17 is wind. 17 is wind. So we should be able to overtake the fossil fuels by 2030. That is the target. So renewable will be 63 and non-renewable will be 37 by 2030. The target. Okay, this is nothing that this is 2022 50 gigawatts. We have already crossed 50. Okay, this is rooftop is only 6.4 we have done against a target of 40. 6.4 against 40. So this is the area where residences also can put up rooftop solar, but it is not coming in a big way. As far as wind is concerned, we have done about 40, and Tamil Nadu has done about 25% of the entire share, followed by Gujarat, which is 20%, and Maharashtra and Karnataka following. Anyhow, we have a I'll just go into the main thing only. In 2020, only 1.4 gigawatt is installed. So there is some sort of a slow growth in the wind compared to solar. In 2022 alone, we have done more than 10 gigawatts of solar against one plus of wind. So that shows solar is growing 10 times the rate of wind. So offshore wind energy is about 127 gigawatt of potential has been identified, but it's a little bit more complicated than putting a solar. Okay, this is just showing graphically that Tamil Nadu is 25%, Gujarat is 20%, Maharashtra is 13%, Karnataka 13%, so on. This is for the wind. So the wind, the problem is, one is, okay, wind does not cause pollution, but it is intermittent in operation. That means when the wind blows, it will rotate. When the wind is not, sufficient wind is not there, it will not rotate. So again, there is some sort of consistency is not there. And the birds are likely to get hit by the wind blades. So that is one minus point, and wind also makes a lot of noise, and which may affect the ecosystem. So only places where it is where humans are not there, I mean, are far off from the residential localities, so you can have wind. So mostly along the coastlines it is put. I think Tirunelveli and Nagarkoil, all these places have got a lot of winds. And initial capital is much more than of solar. So again, solar it is slightly costlier, 4 rupees 50 paise for wind energy against 2 rupees or something for solar. Whereas solar is clean, more consistently available for 330 days, and available at your doorstep, and you can, it's easily scalable. You can put small solar in your rooftop, depending upon the space that you have, you can install. And there is no movement, there is no big maintenance involved, only cleaning is involved in solar. So it makes the job easier. But what is the disadvantage of solar? The disadvantage is sun is not available to you all the 24 hours. So we get sun, effective sun. Okay, it may be available, but not at the full intensity. So sometimes it will be half intense, sometimes it will be full intense. So over a period of time, around noon, you get full intense. Morning around 8 o'clock, it may be a little less. So over a period of day, effectively, if you can average it out, you can save at full intensity for 5 to 6 hours, depending upon the place. So if you take 6 hours, so out of 24 hours, 6 hours only solar will be there. That means it is having a capacity utilization factor of 20%. So the problem is, if you take thermal as 100%, so solar will be the utilization of solar will be 1/5 of the thermal. So if you put a 1 megawatt thermal and 1 megawatt solar, so the thermal is theoretically, hypothetically, thermal will generate 5 times more than solar. So that is the thing. We can say, a drawback or minus point. And another thing is, because of this, solar cannot exist on its own. As of now, the solar can pair with somebody else. So it can be solar plus batteries. It can be solar plus DG set. It can be solar plus grid, that is fossil fuels grid. So solar can work with others, and solar by itself will not be able to satisfy with the today's technology. And okay, it has to be free from shadow, and we have to keep it clean. And if there is some dust on the solar panels, light will not be received properly. Therefore, we need to keep the solar panels clean. And solar panels are horizontal, unlike a boiler which goes vertical. Here it is horizontal. You need a lot of land space. Now, so we have to conserve land space. We have to identify land space. So we are taking various decisions to overcome this problem. As a solar module prices are concerned, it is now damn cheap compared to the rates it was existing in 1976. So it's roughly 20 rupees or 30 rupees per watt, between 20 to, with all the duties and other things. Now, what we have seen is the battery prices are coming down. With all the electric vehicles, the battery prices will, and many now BEL and other companies are also making lithium batteries in India. The battery prices will come down and will make it more affordable to store energy. So that even though the sun is not there for 24 hours, you can save the amount of energy in your batteries and use it in the night. And that may become economically viable in the next few years. Okay. So it is something like, I will give an analogy. It is something like storing in major cities, water will come for 3 hours and you store it in sump and then use it. So in a similar way, now when the sun is shining, you should store as much energy as possible. And beyond what you can use, balance you should save it in batteries. So that is the thing. If that works out, solar will be an excellent solution. So where all we can use now solar, and the more you use solar, you don't use fossil fuel, so you're doing energy conservation. So that's what I'm saying. Solar cooking, okay, not that popular, but some products are now available, but we are still, you have to wait for a long time for the cooking to happen. So it is still not a very good product as such, but it is definitely, people are working on that. Solar water heating, this is very, very famous. I have not seen that many installations in Tamil Nadu, but in Karnataka, a lot of installations. And I have also installed in my house. It's working for the last 25 years. Then charging of electric vehicles. So once you charge battery with the electric vehicle, for a battery for electric vehicles with solar, it is pollution free. So one of the argument is you use fossil fuels for charging the battery, then how you can claim batteries, electric vehicle is not causing pollution. The battery is charged by a power that comes from thermal set. Solar powered pumps is a boon for the farmers. Solar powered ventilation fans, portable lanterns and emergency power supply instead of DG sets is a good option. Then solar powered street lights are getting very popular. You just put it and leave it. There is no connection to the mains. So automatically it will take care. So there is a battery which gets charged during the day, and then night you get the light. Then producing power. Then people are also coming out with fencing for forest areas to scare the animals, not to kill them, but to scare the animals. Solar fencing is done. And STP and WTP in gated communities. This is a very good application. I think solar must score. And many times it is problem is because the residents are not coming together in sharing the expenditure, and it is getting stalled. Otherwise, this is a very good application for solar. Okay, this is just showing you solar thermal. So directly the sun is heating up the panel, and the convection, due to convection, the water circulates, and then the hot water is available to you. So this is now very popular. Almost all, many of the houses, 90% of the houses in Bangalore are fitted with this. And I am having two solar heaters which are working for the past 25 years without any issue, without any maintenance. Okay, this is another model of solar. This is a solar cooker. As I told you, okay, it's still in the beginning stage. It is not yet popular. And this is a solar tracker. See, if you can move the solar panels to face the sun, in the morning it should face towards east, and the evening it should face towards west. So every day, if you can move it to track the sun, then you will get maximum energy. So east to west movement each day gives you about 15 to 20% extra energy. Okay, and moving it winter and summer, that is north to south, that is tilting the panel, adjusting the tilt of the panel. If you can do it, that is called the dual axis solar. The first one is called single axis solar, where you don't, the tilt is permanent, only you move it left to right, right to left, like that. So that is giving you 15 to or 25% extra power, extra energy. Whereas if you can also adjust the tilt, summer tilt and winter tilt, then you will get 35% extra energy. But the tilting mechanism, and for a larger system, will add to the cost. But this is also being tried out in many countries. I think some Chinese firms are already on a mass scale, they are producing this type of trackers. The solar panels are is the heart of any solar project. So normally, higher the power, you have the higher number of panels.
Over slide over mathematical photo in the notes.
So accommodating the solar panel is the main thing. The rest of the things are very simple. Accommodating the solar panel is something special because you need the land. Where from you will get the land? That is the thing. Okay, so depending upon how you mount, the project is named. If you put it on the roof, it's called rooftop. If you put it on the ground, it is ground top. If you put it on open canals, it's called canal top solar. And if you put it on a lake or river, then it's called floating solar. So you got some 4 types of solar. And this is also conserving energy. Why, I will tell you. This is showing a ground mounted solar plant. You can see the amount of area it has occupied. Okay, hopefully it is a barren land. This is an installation in a foreign country. And this is the rooftop on a tiled roof. So nowadays, I think Tesla has come out with, it's called solar tile. So instead of the normal tile, if it's a new construction, you can put solar tile itself. It's available in various colors. So you can use that, or put the panel for an existing house, you can put the panel over it. So here you are using the natural inclination of the roof to face the sun. This is a factory roof. So these are all the possibilities that we can use, effectively use the solar in the area. Factory roof. Here, this is a gated community. And here they don't want to waste the terrace space. Okay, the terrace space, sometimes you need it for some people walk on the terrace, do some, they don't want to waste the terrace space. So this is an elevated structure on which the solar panel is put. So this is a house in Chennai where it's elevated and put. So the terrace space is saved. And this also acts like a shade, and you can have some dinner or something underneath. So this acts like a shade, I mean, like a cover. Here it is on the RCC roof. It is put on the roof. So it affects the terrace space. This is a side view. You can see the tilt, and generally the tilt should match with the latitude of the place. Here is, hope the picture is clear. Here there is a carport, the car parking area, and this is fitted with solar panels. So whatever lighting and charging of the cars, electric cars, can be enabled from here. And this is the canal project, the first in the world. This is the first open canal project. It was installed in Gujarat by Sun Edison. Location is somebody asked me to name the village. So later I traced it, Chandrasan village, Kadi Taluk, Gujarat. And why this is related to conservation of energy? One is, okay, solar is producing energy. Second thing is, there is water flowing underneath. It keeps the solar panels cool, and lower the temperature, higher is the efficiency of the solar panel. So one is, you are generating 15% more output. So the same solar panel is giving you, because the temperature is low, it is generating more energy. Second thing is, because now the sun is not hitting the water straight, the evaporation is reduced. So they are telling 10% saving in the water evaporation and 15% output electrical. So you got twin advantage. And here is a floating solar. This is a fiberglass body on which the solar panels are placed. So here also you get the twin benefit. Solar panels produce more energy because they are surrounded by water, which keeps the solar panels cool. And second thing is, the area covered reduces the evaporation, and therefore water is conserved. And this is just a structure to keep the solar panel. And this structure is designed according to the wind speed where you are putting the solar panels. The solar panels should be firm and they should not fly away. And so, and then the tilt, the slope between this is according to the latitude of your place, roughly. Chennai and Bangalore will be almost the same. And here is a novelty. This is the ballast, concrete ballast. So the solar panels earlier used to be drilled, anchored onto the roof. But now these concrete roofs, I mean, ballasts keep the solar panels in place. And we can decide this, the weight of the concrete slab can be decided according to the wind speed. So this is, here there is no drilling required. Okay. Now, as I told you, the solar energy is not constant at all the places. The same panel in Chennai will generate one amount of energy. Same panel put in Tuticorin will generate another level of energy, and in Bangalore another level of energy. So it depends on the place where you are putting. Okay. So this has been worked out. What is the sun intensity at a particular place has been worked out by National Renewable Energy Laboratories, NREL, USA, and it's available in the portal. And we can, we just key in the latitude, we'll get the sun intensity at that particular place. That will be useful to design your solar system. How many panels you need to put. So all those things, how many units I will generate in a year, all those estimation, design estimation can be done based on that. condition. So latitude is very, very important. So this is a sample thing which I took for Bangalore, Karnataka, monthly average. So from daily, we make monthly average and then made this bar graph. So the yearly average will be 5.83 kilowatt hour per square meter per day. That is the Bangalore solar insolation, solar incident radiation. Chennai is 5.08 annual. Because some other months Chennai is very low. The intensity is not that. So like this, you can find out for your place what is the thing. Once you have the GPS, you know the latitude. Key into the portal, you will get this figure. And now, where the land is scarce, we can locate, we can circumvent the problem by putting it on the roof, or by putting it on the canal, or by putting it on lake. Of course, lake and canals can be done only by the government. That's a government decision, but your roof is available to you for putting solar panels. So the targets can be achieved if owners come forward and put solar panels on their roof and become an independent power producer. So this is the thing, no? Solar makes you to become a power producer. Earlier, it was only the prerogative of bigger companies. You and me cannot do something, cannot put a boiler, but we can put a solar plant and become a power producer. So depending upon, I listed some applications of solar. It can be met either by off-grid, which is standalone. Some of the applications can be met by standalone. Some of the applications can be met by that is off-grid. Some of the applications can be made by hybrid. That is solar plus wind gives you more stability, because solar will stop generating power after sunset, but wind can still generate something. So overall, it will balance out. Or you can have a hybrid of normal on-grid, which is solar, plus off-grid with some batteries which can come into effect after sunsets. Or it can be on-grid and DG set. So you have different possibilities of mix and match to meet a particular application. So we have told that we need an alternative source to support solar plant during after sunset hours. So battery is one great possibility. Grid is another possibility. So two things are grid plus, in case grid fails, DG set. Okay, this is standalone. Is not connected to the grid. So you can use this type of, it's called off-grid solar. You have nothing to do with the grid. You got during sunset hours, the battery, the energy stored in the battery will be used. So you have to design accordingly. And under this case, that is standalone cases, we have street lights, solar street light. During the day, you don't need lights during the day. So during the day, let it charge the battery, and the night you use it for the battery will supply the power. You can even design, you can size the battery so that even one day sun is not there, it is raining. We can put sufficient power in the battery to look for one day sun holiday also. It can take care. You can have portable solar lanterns, air conditioners, EV charging station, relaxation vans. So these are vans fitted with refrigerator, TV, everything. And they move from, they are caravans. They move from one place to another place. It's mainly used for picnics. The picnic spot, you hire a parking area, and then, whereas all the facilities are available in the van for your day-to-day needs. The solar powered boats, I think Kerala is using solar powered boats. Then houses not having regular electricity. That means if you are far away from the grid, or your place is such that power is not reliable, you can use this off-grid solar. Then other things like, I have seen some other foreign countries, your garage gates are all opened. Power for the locks are coming from solar power. So opening of gates, whatever required for operating the actuators, all come from solar powered, solar charged batteries. Just pictorial view. This is solar street light. It's having a lithium battery, and the size of the battery is for how many days you want without sunshine also the lights to glow. So we can generally take 2 or 3 days and design the system so that one day it rains, there is no sunshine, also your lights will work. These are portable solar lanterns, so you charge, then disconnect and take it out. The solar LED lantern, easy to carry. Solar powered pumps. It can be a DC pump or AC pump. Okay. So you can use both the type of pumps. Accordingly, the controller will change here. You can have with battery or you can. So this is a very good. You don't have to depend on the power grid at all. Self-standing pump controller. This is also very popular because you don't have to connect to the grid. There is no metering, so it's very simple. Here is this is just for the DC. This is the controller. For AC, this is the controller. This is from Jindal. Sorry, Jain Solar. And here you can see a typical pump application, and you can see the same structure is used to mount the solar panel as well as house the syntax tank. And these are the vertical pumps. It can be an open well or a bore well. So this will be inserted. So they are lengthwise they are long, and circumference wise they are small. So meant for bore wells. So this type of applications solar can be used. So totally sun energy, totally energy conservation. No fossil fuels involved. Okay, this is just a block schematic. If you are using a AC pump or a DC pump, both are possible. This is an interesting application. What I saw when I was in sometime in the USA. You can see the top here. The top here is a solar panel. So these are kept in public places, and it is having a compactor. So whatever garbage you are putting, it gets compacted, and it with compaction 5 times the normal capacity you can have. That means if vehicle is coming to clear this garbage every day, now it can come once in 4 days or 5 days, like that. So it saves unnecessary these vehicles coming, and the corporation lorries to come and clear. No? So they can come once in 3 days, like that, and clear, because it's having increased capacity. So it's very, very popular. Now I'm seeing in all the public places this type of garbage collecting bins, solar operated. This is the relaxation van. You can see inside, if you see all fridge, TV, everything will be there. And these are solar panels put on the roof, and the vehicle just drives to the camping place where it is parked. And during the travel, they can enjoy all the comforts. Instead of using the petrol, they use the solar electricity. So the other applications are, okay, you can use grid connected power supplies. You can have bank ATMs operated by solar energy. You must be knowing that Google has their offices completely operating on solar in USA. The toll gates, parking areas in the parking areas and parks in gated communities. And what I was telling you, sewage treatment and water treatment, which are to run 24 hours, you can't stop it. And common area for lifts, lighting, etc. Because you have got a huge roof over the gated communities. On the roof is only thing if people have to come forward and implement this. In the long run, the money will be you will make up the money that you have invested. But only thing is people have to come forward. But I think there is some, it has to catch up. And so the solar panel charge the battery, and these batteries to inverter can be connected to the grid and during peak times, and thus save the need for a peaking power plant. This is why this improve the grid stability during peak hours. This type of system is adopted in Australia and some parts of California. India also on trial basis in Delhi it has been implemented. Tatas have put about 1 megawatt with some batteries. So whenever required urgently, they will release this power and bring the grid, make the grid stable. And this is much better than keeping a thermal plant idle for the peaking power alone. Whereas because this battery with the inverter is very fast in response, so they have found that the grid is more stable with this kind of an scheme. Okay, this is just a block schematic of a solar panel which is connected to the grid. So both the grid and the thing, the only disadvantage is whenever the grid fails, to make the some lineman will be working on the grid. So by law, by this thing, the solar panel, the panels will have to be mandatorily switched off. So you will not be able to use the solar panel when the grid is down. So that is the only thing. Otherwise, this is cheaper than the off-grid system because you don't have the batteries here. So this is just a solar panel installation of my residence. I'm just showing. This is the inverter. These are for maintenance purposes, DC side, AC side control, DC side control. There are lots of fuses and other things. You can, during maintenance, you can pull it out. And this is the meter, which is measuring the amount of energy that is pumped to the grid. And I think this is the one where there is a changeover to the DG set. So normally you have the grid and the solar panel connected to the grid, on-grid system. When the grid fails, the solar panel cannot function. So at that time, it will switch over to the grid. I mean, it's a DG plant. The DG will be supplying. So this is another example of an hybrid solar system. Okay. Now, basically, if you think about a solar plant, I have told you first you have to mount the solar panels. So mounting of solar panels need a structure, and you need the solar panels. You need the solar panels of sufficient number to meet your power demand, and you need sufficient area on your roof to accommodate the structure as well as the solar panels. Then all the solar panels need to be wired and brought to a combiner box. The combiner box goes to a DC side distribution board. Just it is a safety, fuses and for maintenance purpose. If you are doing something, you can open it out. So the DC side, DC will not go into the inverter. Okay. Then you have the inverter and AC side protection. That means if you want to switch out, take out from the grid, you can disconnect here, and then work on the inverter. The grid power will not flow back into this side. So, and then if you are using an off-grid system, then battery will come into picture. So these are the major components. Apart from that, lightning protection. Then for safety, you have to do earthing. For a small system, these are the things. Of course, bigger systems will have some more protection, some more meters will be there. You should know the wind speed, you should know the humidity measurement, so all and temperature of the place. All those things are. But for a smaller system, a rooftop system, for residential purposes, these are the major things. Apart from that, small things like lightning protection and earthing. So with this, you can design a system. And normally you have, see again, where does energy conservation come here is, if you improve the efficiency of the solar panels, again, you are conserving more energy. That is a thing. So you have monocrystalline, polycrystalline, these are used mostly in residential systems. And all the bigger systems, only monocrystalline is used. But the efficiency is about 1 or 2% more than polycrystalline of these panels, monocrystalline panels. And nowadays, with I will just tell you, share one information. In 2015, the efficiency of the solar panel was about 12%, 12 to 15 maximum. And now we are talking about efficiency of 20, 22, like that. So over the years, the efficiency has improved. How it is improved? So this is a bifacial panel. That means the front side also will receive light, the back side also will receive light. You can see the diffused light, the reflected light also hits the panels. And this is called an off-cut panel, where the wafer is cut into half, and it is like 2-in-1. One structure with 2 panels, so the current is divided by 2. With the result, the losses in the panel is reduced. So this is, one is bifacial, both sides receive light. Off-cut, the losses are reduced. So with this 20-25% more output this can give. This type of panels nowadays. 2015, we were having only 250 megawatt mostly used. And now into 500 megawatt is very common now. So we have doubled the capacity of the solar panels, the power capacity. In one panel, we can get 500 watts. And how we have done efficiency, we have improved. One is by dividing the current into 2. So now there are 2 paths. And also receiving light in the front as well as the back. So that way the efficiency has gone up. So and second thing is, the panels are maintaining the quality for 25 years. This is another Canadian solar panel. So here also you can see. This is off-cut panel. And solar panels need some cooling to carry away the heat. I have told you that the efficiency will be higher. So we should not place the panels flat. We should leave some space between the roof and the lower end of the panel for air to pass through. So convection will carry away the heat. And you can see now 27 years warranty, performance warranty, 12 years product warranty. That means at the end of 27 years, the efficiency of the solar panels must be compared to what you purchase new. If you take it as 100%, the efficiency should be more than 85% at the end of its life, 27 years. So much the quality has improved. Over 27 years, the deterioration is just 12 or 13%. And you see, you are now getting 10 years warranty for inverter. So that means in one solar lifetime, you will change the inverter once. That when you do the costing, you should take like that. But it was 5 years in 2015-16. It was 5 years only. So in this 7 years, people have improved again, and they are able to offer you 10-year warranty. So much of development is taking place because of the constant pressure on them. Okay, this is how you see. So one single panel may not be sufficient to do the job, so you have to put them in series to increase the voltage, and you have to put them in parallel to increase the current. So what we do is an array. So it's like a train. So you have so many things in series. So each is called a string. This is another string. So, and this entire thing is called array of strings. Okay. And earlier the string size was limited. People never went beyond 500, 600 volts. Then they went up to 1000 volts. Now they are going up to 1500 volts. That means if you have one 500 watt panel, which will give 50 volts, if you put 20 panels, 20 into 50,000 volts, which is within 1500. So one panel is 500 watts, so 20 panels is 10,000 watts. So in one string, you can get 10,000 watts. There is 10 kilowatt. So that is how the thing goes. So now you are able to, with technology, you are able to go for longer strings. Always the panel should face south, and it should be tilted at its latitude. Solar inverters, I will not go into depth. We should produce sine wave with 3%, less than 3% harmonic distortion that is acceptable to the power distribution companies. So what we use is called pulse width modulated, sinusoidal pulse width modulators. Many are available in the market. There is an approved vendor make for all the inverters according to the state where you are. And as I told you, off-grid and on-grid inverters. And now we can use one, when you are using several strings, say for a 1 megawatt plant, if you use so many strings, you can have one inverter, big inverter, which will be economical. But if one inverter, that inverter fails, the total plant is down. So people come out with, you can have multi-string inverters. So you can have many inverters, 1 or 2 strings per inverter, and have several inverters connected to the grid. So that way, what you can do is one fails, others will work. So that is this one. This is string inverter. For each string, there is an inverter. So if one string goes, the rest of the strings will work. Well, this is a central system. If this inverter fails, the entire plant is down. And here is a new one. Each panel is having a small inverter block, which is fitted behind the panel. So it, at the point of generation itself, it converted into AC, and then it is synchronized here. The idea is, since the DC side is very short, DC length is very short, efficiency is very high. Though initially it will cost more, the efficiency you get very high, above 90% here. Yes, in normal inverter, the efficiency will be around 70%. I mean, the string, the efficiency of the thing will be from the solar panel to the meter point will be around 70%, whereas here you will get very high efficiency. Here 2 strings I am combining in one inverter for the house. These are all economics, basically economics. How, whether you want to put individual inverter or you want to put 2 inverters into one, it's all. And this is one foreign company called Enphase USA, is Californian company, who is making this. It's called micro inverter. That means each panel will have a small box, which is called the micro inverter. And the advantage is one fails, only that fails. Other things will work. But cost-wise, the efficiency is of the order of 95 to 97%. So this is what he is claiming. So there are ways to improve the efficiency. The normal inverter, 70% is the efficiency. And one of the, this is about 5% you lose due to dust settling on the solar panel. If you don't clean it, you lose 5%. So you have to periodically clean with water. And for maintenance, you can use drone services to see whether any hotspot is detected on the panels or any glass is cracked. All these things you have to use for a bigger system, I am talking. Now, earlier there was a lot of water wastage, so people were telling solar panel is not good because you have to use a lot of water, and where do we go for that much water? Okay, so then they came out with some coating on the panels, and the coating will last for say 3 years, and it will not allow any dust to settle or stick to the panel. So it will be easy to clean it, and the water requirement was reduced to 0.75 liter of water per panel. And now some people are claiming that it can be cleaned without water itself due to with some static charge and some technique. But it is to be proven in the market. It is not yet come. At the moment, this coating is available. People coat the panel, and it is the coating will allow light to pass through, but it will not allow dust to stick onto the panel. It will be easy to clean. So that is a trend which is coming, and there is an answer to the critics of the solar thing. And here is a normal manual brush. You connect the hose pipe on the other side. So it will, at the where you are giving the pressure, it will spray the water, and then the brush will clean. So this is useful for some smaller rating and smaller number of panels. And here the panels are cleaned by the brushes, which this is a semi-automatic. Once you put it here, it moves from this one end to the other end, and then it cleans the panels. So these are now commercially available, and you have got automatic also, robotic cleaning also. But so that is the thing. Okay. Another installation where we have put the solar panels. So I think we have come to the end of the presentation. In conclusion, I will say like this: there are a lot of ways to configure the solar panels, lot of ways to locate the solar panels, improve upon its efficiency, and a lot of research is going on in the battery technology. And once the battery technology matures, solar will be able to save in 6 hours what is required for the next 18 hours till the sun comes again. We'll be able to save at a very economical this thing, and then we will be able to see more and more component of. You saw that fossil fuel was supplying most of the energy, while solar panel is supplying less. I told you because the capacity utilization factor is only 20%. That means if a thermal plant can produce 5 units, solar plant will produce only 1 unit because it is going to be on for only 6 hours. And that story will change. It will be able to compete once we have the battery technology well developed, which I think must be a matter of few years. And another thing is, within the solar panel, there are many ways to configure. Locating on the dike, there are innovations because land is problem. People found out a solution in the dike. People have found out solution in the canals. And there is no land acquisition problem. There is no court dispute. So there is a lot of advantage. If you put it on your own roof, that is your house, so you can put it on your roof. There is no land acquisition issues. So I think in the days to come, you will see more and more solar, and wind will be a supporter of solar. Wind cannot challenge solar. Wind can be a supporter of solar. So with this, more and more applications will come under solar scope. And in fact, there's a lot of thinking that why not use solar with our induction stove. Okay, solar thermal cooker is not that established, but we can as well use solar energy with dedicated solar energy for kitchen purpose. So this, I mean, is in my mind. I have to implement it. So there are many ways. One is improving. I mean, in conclusion, changing our lifestyle. Try to share the lift. In many countries, people don't want to share. I mean, during COVID times, of course, if one person gets into the lift, other person doesn't want to get into that lift because he may catch COVID. But over time, people have to lift should make less number of trips if wherever possible. And similarly, people have to use cars in a pooled fashion, and where pooling is not possible, we have to depend on public transport rather than taking car for one person. So like this, these type of lifestyle changes should come, and we should see Delhi and other places, they are all using air purifier inside their houses, because they say even inside the house it is not safe. You have to wear N95 mask even when you are inside the house. How is that? So the thing is, this situation should change. You can't with so much of dust. In fact, just I forgot to tell you share one of my experience. I was in Bhilai in 2009, 2010, correct, 2009. And there was a sort of puncture in the ash pipe, that is from the electrostatic precipitator, the pipes which are coming got punctured because the ash is really abrasive. And why it was getting punctured, we were not knowing it. It was occurring frequently. And when and then I was there for some time trying to fix the problem. When I returned back after a couple of months, I was not able to breathe. And doctor gave some antibiotics, but the problem continued. Finally, I went to one lung specialist. He said, your lungs are badly damaged. You are not able to, it has become hard. There is some chemical interaction in your body. What is that? Then I remembered, no, sir, I was in Bhilai and there was an ash leakage. And then he told me, yes, that's the problem. And okay, he put me on some steroids for some time and I became all right. I just wanted to share that the particles, the ash is so fine from the electrostatic precipitator. It's just like a talcum powder. It just gets into your lungs very easily without your knowledge. And the problem starts after 2-3 months. So this is the way it is. So there's something has to be done to whether fossil fuels will be there for 100 years or 150 years. Okay, that is somebody's guess. But the pollution is something that has to be done immediately. So with these things, I thank you again, and then I wish you a happy Energy Conservation Day tomorrow. And then if there are questions, I will take. Hello? Hello? From Mr. Selvaraj? Hello, am I audible?
Yes, sir, you are audible. Sir, capacity that exists in India today now for the solar PVs?
I'll just, shall I come out of the share? Shall I stop the sharing?
Yeah, I think you can stop.
Now we can see each other.
Now we can see. What is the capacity now that exists in India today for solar PVs?
In terms of capacity, I think the MNRE has arrived at 750 gigawatts. That is the installed potential, what we call solar potential. 750 gigawatt, assuming 3% wasteland for each state. That is only wasteland. Now that we have got, now I think almost many of the tenders are coming asking for floating solar. They have put in Kerala, they have put in West Bengal, wherever water is there, they are putting. And presently, our total installed capacity as on date is 400 gigawatts. And now solar potential alone is 750. So we can whatever you are having, you have the double the capacity. So there is no, you see, we have done only 6 gigawatts of rooftop solar. You got a lot of railway stations, you got a lot of parking lots, then individual, now they have conducted drone study. Even in Bangalore, they have done drone study. Fantastic potential is there. Even Bangalore alone can generate gigawatts of solar power on rooftop. Only thing is the economic investment and return of investment, those things are to be answered. People want, they are expecting within 3 years to recover the money. That is not happening because when solar panels are becoming cheaper, government also reduces the rate. Okay. And one thing is when the electricity board increases the rate, our return of investment becomes slightly faster. I think in Maharashtra, it is easy to recover your investment much faster than in Tamil Nadu. Okay, Tamil Nadu has got 100 units free. So that will, many people who are only major consumers, those who are using air conditioners only will come forward, are thinking about solar. The rest of the people will not think about solar because if you consume 200 units, 3 rupees you will be paying per unit. So 100 units free, another 100 units, 3 rupees, 300 rupees. So why to put a solar? So that is the thing. But there is a lot of scope in residential solar, plus all railway stations, airports. If you can, I think Cochin Airport has been fully made solar. So like that, many airports, if they do it, there is tremendous potential. So 750 is what is identified by MNRE in the report. And 750, today we are only, that is 750 over 400 what you have already installed.
But what is the manufacturing capacity that exists?
Manufacturing capacity is now going up. See, for example, Adani is having about 5 gigawatt manufacturing capacity. Adani, Wari, and Vikram Solar. Vikram Solar is on an expansion. He is having 2 and he is moving to 5. Wari says is 5, but some are targeting only mostly foreign market because they get more dollars. So you can say right now it is, if you add up all the things, maybe 15 to 20 gigawatts is what will come now. BHL is only 250 in Bangalore. There are Tata Solar is there. They are 1 gigawatt or so. So if you see, it will be between 10 to 20 at the moment, not beyond that. We are dependent on Chinese import. But people do import because of anti-dumping duty. They do it in some particular fashion. Do some assembly here and it becomes, that is the wafer comes from China. Rest of the things that panel in the aluminum frame plus glass and terminal box, those things can be made, being made in India and integrated to become the solar module. So you can say, but the main heart that comes still from China. Only Reliance is thinking, Reliance and these people are thinking, but right now it's all imported.
Sir, there are some queries in the chat box. Sir, it was an excellent talk, sir, by you. Really brought all the governments of solar energy and other conservation measures. Thank you so much, sir. Really, it was a knowledge treat for all of us in Energy Conservation Day. Thank you so much. Now I tell you, read some of the questions, sir. There is one HP to everyone. That is with increased focus on green hydrogen energy, bio CNG and so on. Will the attraction of solar energy for reduce? So as it calls for a lot of land, there is 5 acres per megawatt, and the land will be turned barren, and the load factor is only 20% less. Yeah, some throw light on that, sir.
Yeah. Okay, that as I told you, the load factor is 20% because sun is available only for that much time. And only thing is we have to storage option. We have to store it. That is our thing. Both wind and solar. You can't use it like a thermal plant because it will blow sometime, wind will not blow some other time. So we need to store the energy and use the energy. That is one thing. Hydrogen is a possibility, yes. Green hydrogen, India, they are saying India is going to be a leader in green hydrogen. And green hydrogen has been supported by the Japanese a lot. In fact, hydrogen cars were first produced by Toyota, and it was used in I think it was given to some customers in California. But they are not able to maintain the supply of hydrogen, after which people have gone to the management then decided to replace with an alternative car. Sufficient supply chain is not there. Supply chain is not there, but in future, I think our Ministry of Minister Honorable Nitin Gadkari is also having his own hydrogen car. But the thing is, it will take time. And as such, if you see the government plans of by 2030, and solar is still going in a big way. I think there is no stepping back as of now. But hydrogen cells are being talked about for vehicles. But when it will come, I have no idea. It is,
Sir, one more query, sir. That is one Mr. Saravana Kumar, former Director of Cognition Technology Solutions. He has asked what are the possible hazards or how can we avoid in solar power plants?
The solar, see, one thing that is talked about solar, is some fires have been reported. Okay, the fires have been reported in solar, some of the solar plants. And the main thing, the reason which is given is the presence of hotspots. That means, while in general, many of the solar panels are cool, some panels take extra load, and there are some, they develop some hotspots, and later which it develops into a fire. And once it takes fire, it spreads to the other panels. That is the problem in solar power plants. Now, the two things are there. One is, if a solar panel is shadowed, shadow is one of the enemy of solar power plant, there can be hotspots. Now, people say, okay, if a particular panel is shadowed, I don't want that power. I would rather, if a shadow is falling for a moment and clearing, like a aeroplane is flying over a solar panel, and there is a shadow, but the shadow disappears. It's a vanishing shadow. But there is a permanent shadow, like a tree, which is whose shadow is, or some over a tank is there. That tank shadow is falling. Then there is we cannot operate. We should bypass that panel. If a particular panel is shadowed, so there are some inbuilt the scheme made that if a particular panel is showing signs of shadow, then that panel is bypassed. So it's called, it's called bypass diode, which is put into the circuit by the manufacturer himself. So if there is an unbalance in sharing, automatically that circuit takes into account. So we have, and then another thing is, when you're using large arrays, okay, you have mixed up large arrays, and some array, one particular panel has failed. So in one array, 50 panels are there. Another array also having 50 panels, but 2 panels out of 50 has failed in one array. So this is having 48, this is having 50. Then this 50 and 48 may try to influence each other, causing this particular circulating current. Okay. So to that extent, what they have done is there are some diodes put in the circuit, so that it will not be able to feed the power. It should not be able to circulate between two rows which are not equal. It is one is having 50 panels working, other one is having 48 panels working. Then 48 and 50 should not be connected together directly. So now some in the scheme, these conditions are taken care. Now, third type of problem is somebody breaks a solar panel, for example, which you have not noticed. If in a small, in a small system, you will notice it. But 3,000 panels are there in a 1 megawatt power plant. 3,000 panels. In that, somebody has played cricket, he has hit the cricket ball, and it is landed on the solar panel. You have not noticed it, and the glass has broken. This happened in one of my friends. Now, what happens? Since the glass is broken, the panel is now exposed to weather change. So, in that case, there can be some short circuit or hot spots likely to happen in the damaged panel because you have not even realized that there is a damage. Now, one of the things that is being done is at regular intervals, they will drive a drone. Drone will make one round with an infrared camera, and it will find out if any visible damage or a hot spot is there. And then it will tell this particular panel is showing higher temperature, like that. But that is one method of knowing and then taking timely action. Okay. So these are some of the, and second thing is lightning. If lightning hits it and you are not properly protected it, then again, so the surge suppressors, what is called surge suppression, is very important in a solar panel. So if there is a lightning, the lightning should be quenched at the instant where it is occurring, not allowed to be traveled to the other point. At the disturbance site itself, it should be quenched. So lightning must be given a separate, you need a lightning arrestor and must have an independent lightning pit, sorry, earth pit for lightning. Okay, that is very important. And another thing is where I showed you that for maintenance, some two boxes, AC side box and DC side box, they will have surge suppressor in each line, so that no line disturbance should be able to travel from the grid to the solar panel and from the solar panel to the grid. You should not, both ways you should not influence each other. So there is lighting surge suppressors are a must, and they are provided in each line. So if there is a disturbance in that line, that will be connected to the ground. So these are some of the protections people have to take. Otherwise, I mean, these are all coming because we something we just ignore, and later on it becomes a problem. But if you take care of these things, the chances of a fire happening is very, very little. See, in my house, 2017 to 2022, it is working. Okay, and the thing is, you have to make one earth pit exclusive for lightning, and earthing rod should not be mixed up. You should not try to save money by mixing this and that. So earthing rod for the lighting is separate, earthing rod for the panel is separate. So everything should be made separate so that one should not superimpose on the other. So some of the precautions, whatever is mentioned, have to be taken care. But during installation, the main culprit is installation. What I have seen is people try to join two things with a nail. Okay. Another thing is you should not mix a solar panel frame which is aluminum. You should not mix it with copper. So if you have a copper lug and connect it to an aluminum frame, then there will be some electrolytic action between the two, and the corrosion will take place. So slowly the connection will get cut. So these safety things, and there is a method. If you are using copper and aluminum, there has to be steel in between. You should not mix directly. So during installation, many of the safety things are bypassed because the contractor wants to do it and get his money and go away. Whereas you have to live with that solar panel for 25 years. Solar panel life is 25 years. So insulate, and no cable should be put on the ground because the terrace gets heated and the heat gets passed on to the cable. So it should be at least 2 centimeters for the air to pass and cool. So these are some of the good engineering practices that have to be followed. I think if these things are followed, the chances of occurring is remote. And added to that, for any other things other than installation, that is like breaking the glass and that type of happening, or some tree falls on the panel, something breaks, or some stone falls on the panel, something breaks. That at regular intervals, at least once or twice in a month, they have to run a drone. Such services are being offered. And then you see if any hotspot is there. The main reason is hotspot.
Saravana Kumar sir, sir, you want to ask any more questions, or sir, yes, sir.
Yeah, one quick question. Though the solar energy seems to be the one of the best environment friendly energy, but however panels, what about the panels? What materials are being used for panels? I am not sure whether they are environment friendly. Are there any alternate options available for manufacturing those panels? Because the materials, whatever being used, they are environment unfriendly, right?
Yeah, correct. It's a very good question. Yes, I agree. There are 3 stages in a solar panel. Okay, we say solar panel does not emit carbon dioxide. Okay, and similarly we say electric vehicle does not emit carbon dioxide. True. At the same time, what is not true is there are 3 phases. One is manufacture or birth of solar panel. Other one is the life of the solar panel. Second thing is end of life of solar panel. Okay, so what we are doing is like energy conservation. But during the birth of solar panels, there are a lot of foundry and other things involved, especially some 2000 degrees centigrade heat and all those things are there. At that time, definitely carbon dioxide will be released. Okay. And regarding the toxic materials, what you are referring to, now the solar panels are 99% recycled. So the end of solar panels, end of life cycle of the solar panel is not thrown away, because if you throw away the solar panel onto the earth will become toxic, and you will have mountain of solar panels, because the way you are putting 500 gigawatts, solar capacity solar panels, when the life is over, okay, you will have millions of solar panels, and you won't know how to dispose it off, and it will be a mountain of solar panels. So what people are doing is recycling. Now the recycling again produces carbon dioxide, no doubt, but all the materials are recovered. 99% materials are recovered and reused. So the toxic things do not go elsewhere, but carbon dioxide is definitely released during the end cycle and during the start cycle. In between, but what I would say is, over a period of 27 years, if you see the starting and the end, that is not much. I think it is livable. That is the answer. There is no other, even for this amount of carbon dioxide that we are throwing into the air, no amount of, you have to plant billions of trees to take that carbon dioxide. So I think it's virtually impossible to do it in either way. There are only 2 things which are, one is in theoretical stage, that is some process by which they capture the carbon in from the atmosphere and then convert it into some fertilizer. There is some scheme, keep it in order. And other one is the solar and wind. Similarly, when we talk about electric vehicles, which is now the talk that you don't pollute and you're environmentally friendly and all those things. The electric vehicles, the motor, the batteries, their manufacturing, the production consumes a lot of carbon dioxide. I mean, it's not consumed, they give away a lot of carbon dioxide. So whatever we are talking about, electric vehicle does not emit carbon dioxide, is only tailpipe emission. The electric vehicle, the tailpipe emission is 0, but not the manufacturing stage. So that is why I said, okay, if you do a realistic analysis, the electric vehicle is getting its charge from the grid. It is getting charged onto the battery. The grid is coming from a fossil fuel. So if you use more electric vehicles, you will burn more fossil fuels. That is the argument. So if you go to solar and charge the batteries, at least that part is over. But whatever you make, that is making electrolytic copper 99.999% pure, and then castings and foundries, whatever that emission, when you make the car body and the motor making, they all emit carbon dioxide, which is to be accounted. And we only see petrol vehicle, how much it emits, electric vehicle, how much it emits. And then if there is something, if this is less than that, we should be happy. But not to say electric vehicles don't emit anything. Only tailpipe emission is 0. So similarly, solar panels do emit during manufacture and do emit during recycling. But over the period of 27 years, its life, I think this, when you average it out, it is less. And second thing is, no toxic material is allowed to go into the earth. It's all recovered and recycled. So similarly, even for lithium batteries, it is to be recycled. No lithium or cobalt can be put on can be discarded. They recover it because that materials are in scarcity. So that is my answer.
Thank you so much.
Sir, volume is not. Selvaraj, I think your volume, your mic is muted.
Yes, there are some appreciations, sir, for you. That Dr. Manavalan has appreciated your talk like anything. He has told a lot of things in chat box. He is very much impressed by your talk, sir.
Thank you, sir. I am very much honored.
Yeah. He is our former deputy general manager of BHL. He was taking care of safety activities.
Oh, okay.
And some more people also. That Darshini has told about your. Thank you very much for your informative speech, sir. And Iswaran Tangavel, thank you very much, sir, for your time and knowledge sharing, sir. Like that. So the overall it was good, sir. I have a query, sir. But we have a lot of residential area, rooftop plant. There's a lot of potential, lot of target and all there. Is there what is your advice, sir, to go for rooftop? Whom can go for rooftop? Whom it is best for going for rooftop, sir?
Who means you are asking about the supplier?
Yeah. Rooftop panels in the domestic area. No.
Yeah. See, now one is one of my. I mean, I have gone to Vikram. I have used in 2017 Vikram Solar, but some people have used Wari also. Wari is also good, and they are mostly exporting. So you can go for Wari or Vikram or even Goldie is also there. Canadian Solar is there. So, but there are some dealers for the same. Okay, there are some dealers for the same. One VRM technology in Kodampakkam, Chennai. He is dealing with several brands of solar panels and several brands of inverters. You have so many options. You have Exide also coming up. You have got Polycab coming with their own inverter, I think plenty of suppliers coming with inverters. So now Growwatt is there. Is a Chinese company in India. Then there are some German companies. Fronius is there. So many inverter makers. See, inverter and panels, good make you should capture, and other things are small, not many these things, but these varieties are offered by dealers. Those dealers, some other one dealer with whom I have been interacting, and I got for my brother's house in Chinagar, Chennai, is VRM Technologies. They are having good clout also. Representing so many brands, so you can approach them. And I think that January 21st, 22nd, 23rd, the 3 days solar exhibition is there in Chennai. I don't know whether you will be able to go to Chennai. Then you can see a lot of vendors there at this thing, the trade grounds international trade going in Chennai. I think if you are aware of Chennai, there is an exhibition. A lot of companies are participating. So the thing is, you go for reputed panels.
Excuse me, sir. Which date, sir?
I think January 20. I will in January 21st, 22nd, and 23rd. I think I will just confirm it to Mr. Selvaraj. I think from whom you can.
Okay. Okay. Thank
I
you.
received a mail already, but
Right,
I have to confirm the date. But it is January 3 days. It is available.
Okay, sir.
And in that type of a thing, you will find a lot of vendors coming, and you can see variety of products. Batteries, you can find so many makers of battery, and then so many makers for solar panels. Tata is there. Even of course, even BHL was selling for open sometime back. In fact, in 2017, I got a quote from BHL also, but BHL was a little bit expensive compared to others. But if you contact this VRM, he is in Kodambakam, Chennai. He is representing many brands.
Right, sir, you share the information, sir, so I will forward to all our members and other invitees.
Okay, I will do that. I will do that.
And some more appreciation for you, sir, that Aga, Darshana has appreciated, Agas has appreciated, Dr. Rajakumar has appreciated. Lot of appreciations for you. And TS Tarisha, Naina, like that. So many people have appreciated your work.
Good. I mean, I also thank them because you have now given sufficient time. At least 1 hour you have given.
People also hurry, but anyway, it's a knowledgeable talk. I want to ask one more question, sir. Is it economical to go for rooftop for the domestic area?
Yeah, see, I will tell you one thing. If earlier we can make money with solar. Now you can use solar to save money, not make money. In the sense, if you are consuming 500 units or 510 units now, and you are paying 2,000 rupees, your bill will come. You can reduce your bill by putting solar to 500 rupees, 600 rupees, like that. Okay, by putting solar, you can reduce your bill from 2,000 to 500, like that. You can reduce it. But if you do something extra, TNEB at Tamil Nadu government is not going to give you money. Okay. So the thing is, if you are using air one of my person to whom I suggested this 5 kilowatt inverter, 5 kilowatt solar plant in our village, he is very happy because he is using 2 air conditioners minimum, and then 4 air conditioners. He is having 1 in each room. It's a big house, so 2 is permanently running on solar, and 1 is for the guest if they come, and 1 is on the grid. So he says now he is not bothered about power at all, and he is able to run the air conditioners without being afraid of the power bills. Okay, it will become 10,000 rupees suddenly, or such a fat bill will come. That fear is not there. So he is able to use 2 air conditioners permanently, plus motor, washing machine, mixie, everything is on solar. Nothing is, only 1 air conditioner goes to grid out of 3. So he is very happy. So if you are a big consumer, then you can get your money back fast by saving money. But earlier, in 2017, when I took, the Karnataka government offered me 7 rupees per unit. Okay, so I am getting for every unit, even this is a 25 years power purchase agreement with the government, Karnataka government. I am getting about 7 rupees per unit because of it was signed in 2017. Those who are signed before 2017, they were getting 9 rupees per unit. So there is a question of making money in those days. But today, saving money is making money, not making money as such. You have to save money. You can reduce your bills. Even now, even I think my brother in Tinagar he was showing me. Now they are putting some new charge. Even if your consumption is zero consumption, they are putting network connectivity charge. That means for connecting to the grid, they are charging you 500 rupees every month. So you have to pay minimum 500 rupees or 450 rupees, something, whether you are consuming anything or not. Zero consumption. My brother is generating more energy than what he is consuming. Even though he is also using air conditioners, everything, 20-25 units per day is generating from solar, and his consumption is within that. So he is always generating little more than what he is consuming, but still he has to pay 450 rupees to 500 rupees every month. That is the latest bill he showed me. Thing. So now the TNEB or Karnataka Electricity Board or Tamil Nadu Electricity Board, they want some money, so they charge for connectivity. And Karnataka, they charge for meter charging. So if you put a meter, you have to pay something, some for 3 kilowatt. My sanction capacity is 3 kilowatt. So 3 kilowatt, they are taking 350 rupees. So even if I go out, I keep my house locked and no power is consumed, my minimum bill will be 350 rupees. But I get paid for whatever I am giving separately at the rate of 7 rupees. So if I lock the house for 1 month, I will pay 350, but I would have exported the entire thing to the grid. So I will get around say 1,500 minus 350. So 1,150 I will get. So that is the thing. So big consumers now will get benefited. Small consumers will not get benefited by going to solar. That is the drawback in Tamil Nadu, especially because 100 units free.
Thank you, sir. Some more appreciations for you, sir. Some more people also appreciated that, Sugunt and Adira, Elvin, Serin John, all appreciated your talk, sir.
Thank you. Thank you
so much, sir. Really, it was an information talk. We enjoyed your talk so much. We imbibed a lot of good thoughts about solar power and energy conservation and all. Thank you so much. Now we have got 2 more agendas, sir. Just to wait few more minutes. I will call upon Dr. Kevin, our secretary, to announce the next 6 program, as well as he can deliver some thanks to the speaker, other people. Okay, now over to Dr. Kevin.
Thank you, sir.
Thank you.
Thank you. First of all, I would like to thank our today's speaker for readily accepting our invitation. That within a short notice we have approached you, and thank you. And he is our former general manager in charge of BHL ISG, and he took so much of efforts to deliver a wonderful lecture. So moving on to the agenda, we have a next week program which will be on Sunday, 18th December, on soft skills for success. And the speaker is Engineer Saravana Kumar. He was a former director of Cognizant Technology Solutions, and also he is the honorary treasurer for Computer Society of India, Coimbatore chapter. I request all the members and participants to participate in this program, and to invite your friends and colleagues for this program, which will be useful for which will be a useful topic. Thank you very much, and it's a privilege to propose vote of thanks. First of all, I would like to thank our chief guest and today's speaker of this Energy Conservation Day 2022, conducted by the Institution of Engineers, Tiruchirappalli local chapter. And I thank you for your wonderful lecture, and the responses what you have given was extremely applaudable, because these kind of responses regarding, because everybody will be having that in mind, whether solar after 25 years, what we are going to do, and are we going to dump it, how we are going to manage the e-waste. So many things were there, but you have given a elaborate explanation that we are not going to do so. Anyhow, it is in manageable limit. So that was wonderful, sir. And also you have touched it upon that solar water heater also, which was also very much useful to us. And thank you very much for such a wonderful speech, sir. And we also like to, if time permits, we will be conducting some more workshops in solar, so that everybody, we will call upon more number of members. This being a examination month, majority of our engineering college members, student members could not be able to, were not able to participate in this program. However, they are all interested. They were all inquiring about this. We will be having one YouTube recording, which will be telecasted and will be available in the record. However, we would like to have one more workshop, sir. And thank you very much for your wonderful presentation once again, sir. Thank you to our chief guest, engineer Raghavan, sir. I also thank our past chairman, engineer Kumar, sir, for our past chairman of the Institution of Engineers, Trichurapalli Local Center, for his presence and his welcome address. And I thank other members of Trichurapalli Local Center and members from various engineering colleges, various institutions, our student members, our faculty members, and all the participants who have participated. I thank our engineer Madhuramani, sir, and also thank our host of today's program, engineer R. Selvaraj, our past chairman of IEI TLC, for hosting this program and making all efforts to make this program a wonderful success. I once again thank you everyone. And because this program is being watched by throughout the India, all other centers are having their energy conservation tomorrow. We have conducted it today, and the majority of the other center members are also able to participate in this program. I thank all the members and all the participants from other centers also. With this, I would like to conclude. Thank you one and all.
Thank you, Dr. Kevin, for excellent vote of thanks. Thank you so much.
Thank you for all the people who have shown their appreciation. Thank you.
Right, sir. We have to thank you, sir, for readily accepting, and you delivered an excellent talk today, and we enjoyed your talk. We'll keep in touch as our secretary told. We'll have a future program about solar, sir. We'll have a workshop or something like that, seminar like that we can have, and we'll use your experience towards it, sir. That's what.
Thank you very much.
Yes, sir. Thank you so much, sir. Thank you. Saravana Kumar is also there. Other members, all the members are there. Thank you so much. With all your the feedback link is given, and then people can fill up the people. They will get a certificate, participation certificate. And I request all the people who are all interested, participation, all the invitees to fill up the feedback form so that they can get a certificate of participation. Thank you so much, sir. Good night. With the permission of the chief guest and our Kumar sir and other people, dignitaries, we will call off the day, sir. Thank you so much, sir. Good night. Good night, everyone. Good night.
Thanks all.
Thank you, sir.
Thank you, madam. Thank you, ma'am.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
All right. Thank you, sir.
Thank you. Thank you. Thank you so much.
Thank you, sir.
Thank you. Thank you. Thank you.
Thank you, sir.
Thank you. Thank you, ma'am.
Thanks for the wonderful deep dive session on solar energy, which is the
Thank
need
you,
of the
sir.
hour.
Thank you, sir.
Thank you, ma'am. Thank you, ma'am. Thank you, sir. Very nice, excellent. நல்லா பண்ணிட்டீங்க அருமையா. Only thing இந்த டிபார்ட்மெண்ட் மட்டும் ஒன்னு சேர்த்துட்டு இருக்கீங்க. அது ஒரு பர்టిక్యులர் இண்டிவிஜுவல் நெக்ஸ்ட் அடுத்து. நெக்ஸ்ட் டைம் பண்ணிங்க. ஒன்றும் பிரச்சனை நல்லா வந்து. Thank you so much. Only thing you have to put the feedback only at the end, not in between. அதான் வேற ஒண்ணும் இல்ல பாத்துக்கலாம். அவங்க போட்டுங்க, என்கிட்ட கொடுங்க, கெவின்ட்ட 3 பத்திரிக்கை கொடுத்தீங்க, யாரை ஒருத்தர் போட்டு போறோம். நான் நிச்சயம் இருப்பேன் இல்லையா, அதனால ஒன்று போட்டுருவோம், ஒன்றும் பிரச்சனை இல்லை. மற்றவங்க ஒன்றும் ப்ராப்ளம் இல்லை. நீங்க கிட்ட சொல்லுங்க, ஒரு டிஃபிகல்டிஸ் தானே, ஜஸ்ட் என்கிட்ட ட்ரான்ஸ்ஃபர் பண்ணுங்க. நான் காப்பி பேஸ்ட் பண்றது இஸ் நாட் இஷ்யூ. ஒன்றும் இல்லை அது வந்து ப்ராப்ளம் என்னன்னா, வி ஆர் இன்சல்டிங் த ஸ்பீக்கர் மாதிரி ஆயிடும். ஓகே சார், தேங்க்யூ சார், தேங்க்யூ, நைஸ், தேங்க்ஸ். ரைட் சார், தேங்க்யூ, தேங்க்யூ, பாய் பாய் பாய், தேங்க்யூ, தேங்க்யூ.